In this video on section 3-4, we're looking at parallel and perpendicular lines, specifically how parallel and perpendicular lines are related. And we're looking at three theorems, theorem 3-7, theorem 3-8, and the perpendicular transversal theorem. Okay, by the end of this video, I hope that you can prove these theorems and also other theorems that use these theorems. And we're still covering two geometry standards, G.1.1 and G.6.4. All right, let's review briefly about what parallel and perpendicular lines are. Parallel lines are two coplanar lines that do not intersect. And the notation we use is this arrow. Okay? Perpendicular lines are two lines that make right angles when they intersect. And the notation we use for that is this right angle mark. Okay, if lines A and B are parallel, and lines B and C are parallel, then how do you think lines A and C are related? Now I hope that it makes sense that if A and B are parallel and B and C are parallel, then A and C would also be parallel. And that's exactly what theorem 3-7 says. If two lines are parallel to the same line, then they are parallel to each other. Meaning that if A and B are parallel and B and C are parallel, then A and C are parallel. Okay. Now, theorem 3-7 reminds me a lot of the transitivity property. So you could think about parallel lines are transitive. Okay. If line T and M are perpendicular and lines T and N are perpendicular, then how do you think lines M and N are related? Now, it's not perpendicular. Okay, if you look at the picture, you'll notice that M and N look like they're parallel. Okay, and the truth is that they are. And that's exactly what theorem 3-8 says. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. If M and T are perpendicular and N and T are perpendicular, then M and N are parallel. All right, here's a problem that uses one of those theorems. A carpenter plans to install molding on the sides and top of a doorway. The carpenter cuts the ends of the top piece and one end of each of the side pieces at 45-degree angles as shown. Will the side pieces of molding be parallel? Explain. So the question is, will these side pieces of the molding, will they be parallel? Well, if I bring this side piece in and line up right here, okay, 45 degrees and 45 degrees will make 90 degrees, and so this will be perpendicular. If I bring this piece in, again, 45 and 45 make 90 degrees, and it'll be perpendicular. So both sides are perpendicular to the top. Okay, so by theorem 3-8, yes, they would be parallel to each other. Okay, now this one's a little more complicated, but if lines N and L are perpendicular and lines L and M are parallel, how do you think lines M and N are related? Well, if you look at the picture, it looks like M and N should be perpendicular, and it's true that they are. That's exactly what the perpendicular transversal theorem says. Now this one has a name, and so it's more important than the other two. In a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. Meaning if N and L are perpendicular, and N and L and M are parallel, then N and M must also be perpendicular. Okay, now let's prove the perpendicular transversal theorem. Okay, we were given the hypothesis part if N and L are perpendicular and L and M are parallel. And our goal is to prove that N and M are perpendicular, meaning they intersect to form right angles. Okay, now before we actually write the proof, let's think about why should this be true? Well, N is perpendicular to L. What does that mean? That means this is a right angle. Okay, now L and M are parallel, so these lines are parallel, and from section 3-2, we know, a lot of things about the pairs of angles that occur when two lines when the two lines are parallel. Okay, specifically, we're trying to say that this angle right here is a right angle. Okay, now if you look at it, this angle and this angle are corresponding angles. So by the corresponding angles postulate, they must be congruent. Or so in other words, this circled angle must be a right angle. Okay, or the lines must be parallel. Sorry, the lines N and M must be perpendicular. So let's take those ideas and actually write out the proof. The first statement is that N is perpendicular to L and L is parallel to M. And the reason is it's given. The second statement is I'm going to say that now I need to name these angles. Just so it's easier for me to talk about them. Okay, I'm going to call this angle 1 and this angle 2. Angle 1 is a right angle. Okay, and the reason is the definition of perpendicular. Okay, now the next thing is kind of the key to the entire proof, is that angle 1 is congruent to angle 2. Okay, and the reason is the corresponding angles postulate. Okay, now if 1 and 2 are congruent, I hope it makes sense that angle 2 would also be a right angle. Okay, I would say the definition of congruent angles okay, so if angle 2 is a right angle, then N must be perpendicular to M. And that's by, I would say, the definition of perpendicular lines. Okay, in exercises 6 and 7, or I think 1 and 2, I relabeled them, angles A, B, and D are distinct lines in the same plane. For each combination of relationships, tell how A and C relate. Justify your answer. So I'm just going to draw a picture, which is really helpful to us. A and B are perpendicular. So this is A, and this is B. They're perpendicular. Okay. B and C are perpendicular. So C must be perpendicular to B. I'll draw it down here. So it's perpendicular to B. Okay. So how are A and C related? Well, A is parallel to C. You can tell that from the picture. Okay, and number 2, A and B are perpendicular. This is A, and B is perpendicular. And B and C are parallel. See here, C is parallel to B. So the question is, how are A and C related? And A and C are perpendicular. Okay, this video was about parallel and perpendicular lines and how they're related, introducing theorems 3-7, 3-8, and the perpendicular transversal theorem. There is a second video that goes over more examples and more application of these ideas, but that video is optional.